All right, new attempt. Looks like we are live. Awesome. So, good morning, everybody. Today we are going to play around with the terminal with the goal to write a Sprite Editor. We're going to do that using Golang because this is my favorite language. So let's get started. We have a terminal right here. And well, going to workspace create, that would be me. Going to create a new directory, Sprite Editor. It already exists. Let's get rid of everything. Sprite Editor. All right. First, we're going to do a go mod init of Sprite Editor because that is required. To start a Go project, then we open a main, and in our main we have a small snippet that is going to print success. Awesome. Something wrong with LSP. What is going on? LSP workspace restart. Make it happy. All right. So, first steps first. What is it that we're trying to do? So, our goals. We are trying to create an editor, so we're going to need a canvas of sorts with a cursor, being able to move around. We are going to need to be able to select and set a pixel, so that way we can basically turn on and off the pixel that we're working on. That would be the first step, just on off. The next step would be set a color for a pixel. So first step is just going to be on off, but then we will want to be able to do some more advanced operation, like for instance being able to put characters like this. Hello, car in pixel. Of course, here when I say pixel, I mean basically raw call intersection, not really 1 pixel, but that should be good. So once we have this, of course we will be able to save our work, and as we save, we need to be able to load it as well. So that should be a pretty good start. How are we going to do that though? The good thing is that because we are in the terminal, the terminal itself is already some sort of canvas. We can check our size. So here we have my bottom terminal is 32 by 237. Of course, well, depends depends on the time, of course. So the first step is our canvas. So what I have in mind is that we want a blank screen with just my cursor being able to move it around. So how do we clear the screen? That would be the first step. But because we will want to do quite a lot of things and we explore what the terminal can do, let's see xterm control sequence. That is going to be our reference for pretty much everything. So we look for clear. Screen. Clear screen. Yep, not really Tektronix. What is going on? Well, maybe that is a bit too much for now. Let's say bash clear screen. Nope. Clear terminal sequence. All right, that is actually the one that I was looking for. /033C. Let's try making sure. /033C. Awesome. We have multiple lines. We print that. It clears that terminal. So first thing we're going to do in our test, let's not call it test, let's call it run. I mean, in our case, we're not going to use a context, at least not anytime soon. All right. So first things first, fmt.print /033C. Let's see what does it do. We have multiple lines. We do a go run main.go. Awesome. Now we want to be able to move the cursor around and to keep it running. So in order to do that, we are going to need basically to wait on the keyboard, up, down, left, and right. And in order to do that, it's going to be on the os.stdin. And what do we have here? We have a few things. Well, we're just going to read. So we're going to need a buffer. And because we want only one character, let's try with one. Of course, that is not exactly going to work, but we can start with that. So we do our read. That is going to be, well, let's take a look at the doc. We can see at the bottom, it returns n and error. That means it can fail. Excuse me. Std in read. So if it fails, we just return. If it didn't fail, we are going to basically truncate the buffer with how many bytes we read. So that's pretty good. Of course, here we're going to just add one exception, because if our error is io.eof, then we just return nil, because that would be the expected end of everything. All right. And yeah, just for the fun, we're just going to do a printf here of the character itself. Let's see if that works. Buff of 0, because we care only about the first one. We can say that if n equal at 0, return fmt.errorf unexpected size read. So that way we can call our buff0 safely. And that should be good. Let's see. And so if we say F, and nothing happens, of course. If we do enter, now we are F. So that is something we will have to take care of. We want to be able to unblock the read every single time we type without having to worry about it. That is actually what we call the canonical mode, icanon, and it's just a feature of the terminal that allows you to buffer, by default at least, some text, and only when you tap enter, then it actually sends it. So that would be the default behavior of a read, and we want to change that. So luckily for us, we have a library which is going to be from Golang themselves, .org, if I remember correctly, /term. That is going to give us quite a few things. And let's see, what do we have in our term? The one we want is going to be the one from Golang. So this one, for instance. All right, so what do we have here? We have a get size. That might be interesting to be able to resize our canvas. But really here, it's our make raw. That is just going to basically disable any of the feature of the terminal, giving full control to our process to do what we need to do. Actually, I have a warning. Why do I have a warning on the YouTube thing? Just give me a sec. Tells me that the bitrate is too low. Well, no big deal. It is recorded anyway. All right. So, macro. What does a macro expect? it expects a file descriptor. Alright, so we are going to put raw os.stdin.fd, which is our file descriptor. And what does it return? It returns the current state and an error. Yep, it returns the current state, so it can be restored. Fair enough. TS for temp state. Error. If we have an error, then make raw that failed. And if it didn't fail, though, very important, we need to make sure that we have a differm and that no matter what happens, we want to do term.restore maybe. Yes, term.restore on os.stdin. And the old state is TS. And if that failed, well, we don't really care because it is the best effort. So we can put that like this, and like that. All right. So now let's try again our small program. Oops, go run. So now I'm going to type J. All right. So now, as soon as we type, it unblocks the read. However, you can notice that success is not where it should be, and that's actually one of the features of the terminal that we disabled using macro is automatic carriage return, so CORLF. So by default, when we do a new line in raw mode, so without any of the feature enabled, it's just going to go one line down wherever the cursor is. So if we want to actually have it where we used to have it, we need to explicitly say control backslash or backslash n. So if we try again, we type J, and now success is where it should be. Okay, cool. Next, we will want to make that in a loop. So that way we can basically keep reading and try to get our arrow keys. So we put a small label here, and we go to loop. All right. The buffer itself could be right there, not a big deal. I like to make it like this. Cool. So now it never returns. And let's see. J again, and we can put J as many times as we want. Alright, so except that now if I do Ctrl+C or Ctrl/, well, I cannot go away. So I need to kill that pane and add a mechanism to get away. Because again, as you may have guessed, Ctrl+C or Ctrl/ are like a feature that has been disabled with the raw mode. Because it would be the terminal with upon Ctrl+C that would send a string int, or the Ctrl/ I think is a string quit. But that is a terminal thing, so we disabled it with macro, so we have to handle that ourselves. And the easiest way to do that is not to worry too much about it, and just to do like if our buff of 0 equal at q, oops, hey, come on, here we go. If we were to go at q, then we're going to return nil, and it's going to be the end. And we can also print something maybe. Q press detected, exiting. All right. So now we still have everything as before, and if we press Q, all right, that is better and better. So now we can actually get rid of that from the snippet and try to think. Now, what happens if I put the arrows? Interesting. That is a bit more than I was expecting, but that is actually because of our buffer. There are some keys that take more than one. So, what we're going to do, we need to put 6, because that is taking the maximum size that we can read. And in here, instead of just printing the first one, we're going to press well, we're going to display the hexadecimal value, but I also want to see the actual size that we did read. So like, let's take a look at this. So now we print everything in X. We can even just do like, yes, maybe O. Let's try that. Excuse me. All right, I like that. Maybe with uppercase O. Let's see. So here, that is a delete, that is a backspace, enter, escape, up, down, left, right. So we can see that, excuse me, the arrow keys are taking only 3 bytes, but things like delete take 4, and home, page up, page down, yeah, all that. Pause, pause is only 1. Scroll lock is not detected. Print screen is overridden by Windows. All right, but that's good enough for now. Let's take a look at the next step. So now we do have, again, our up and down. All right, we have our up and down. Let's think about it. So we say like up is okay, so when it is an arrow keys, the first two are always 33 and 133. And that is octal, of course. Let's take a look real quick. Man ASCII. What is 33? This is escape. That would make sense if it is an escape sequence. And once you see, so it's escape, open bracket, and then the number. A, B, C, and D. All right? That should be easy enough. So in the case, we always do our thing here, but if n equal at 3, and our buff 0 equal at escape, so we said it was 0,033, and then our buff of 1 equal at it was opposite. It was that one. I mean, I guess we can just put it like this too. Check if we hit an arrow key. 0,033 escape. So 133 up 133. I said, come on. All right, and now it is going to be ABCD. So we can do a switch on our buff 2, and we can case A, or was it A? I think it was uppercase. B, come on. C, D, default, return FMT, unexpected arrow key value. And we're going to put it as O uppercase, and that's going to be buff 2. All right, and here we can say up, backslash up, backslash down. Oops. Yeah, okay. printf up /r/n, and we do the same for all. So I would say it was down, left, and right. Let's see. Right, actually that was left, up, down. So up and down are right, but C and D were opposite. All right, so now up, down, left, right. All right. So that's pretty cool. Now we are just going to get rid of actually all of the displays because we just want our cursor. And what we can do, just because it always starts to be a bit messy, we can split the keyboard control from this. Maybe we can do it later. All right, leaving everything. So now basically we should have no outputs. I tap something, up, down, left, right, we have no outputs. But you notice that the cursor does not move. So how do we actually move the cursor? Let's go back to our reference and let's say cursor. Save cursor, that actually looks pretty interesting. Resort 2, we will probably use that later. Cursor to lower left corner of the screen. That is okay. Lower left. That is interesting too. But here is what we were looking for. Up, down, forward, backward. So it's going to be CSI, A, B, C, and D. Fair enough. Fair enough. So what is CSI? I think CSI, where is that CSI? That is CSI. Escape, open bracket. So good thing, basically like when we do arrow up, down and stuff, it actually sends us that escape sequence. So when we print it, it should actually do the same thing too. Let's make sure. Echo. So what are we echoing? We say /033 open bracket, and we say that B should go down. All right. C should go right. D, A. Amusing. What if we actually repeat 10? All right. So we can indeed control our cursor. So let's do that. So we said /033 for escape. We could put 0 here too, but it's fine. A. So that is going to be up. Actually, because it's A, B, C, and D, what we could do, we could do that here instead, because we know that we have one of A, B, C, and D. And here we're going to just put that. And that's going to be buff of 2. Let's see. Okay, go run main.go. All right. Up, down, left, right. I can move my cursor anywhere I want. Success! Let's clean that a little bit. So we can put that here, it's a bit cleaner. And it still works. All right. Then what is the next step? We have our canvas with our cursor. Let's maybe put that all that as a to-do. We do have our canvas with our cursor. Now, just for the clarity's sake, we're going to keep working a little bit on that canvas. What I want to have here as an extra would be like the display cursor position somewhere. So in order to have some kind of UI, basically, I want to be able to see the state of the canvas, maybe the size, maybe where we are. We didn't really talk about the size. We'll do that a bit later, I would think. But right now, my idea would be to have that canvas just like we are, and to in a fixed place, like maybe on the top right, and to have basically like X, Y, where is the cursor. So in order to do that, I'm thinking to use that save and restore we saw earlier. So it's going to be escape 7 and escape 8. Alright, we'll try that. Alright, so when we move, each time we move, we do our thing. Each time we move, we do our thing. So now we move. And we want to print the cursor. So because we have a cursor now, because we want to display it, we actually need to keep track of it. So we are going to start putting an actual canvas as a struct, so we can hold some kind of states. Canvas is our main controller holding states. So we are going to have pose X and pose Y. And that is going to be a good start. So yes, it starts to be a bit messy. So let's make some housekeeping first. We're going to do like clear screen. That is going to be nicer. And here we're going to do like we'll clean that up later. All right, let's start with clear screen. The thing is that when we do clear screen, each time we do that, the canvas position needs to be reset. So we can add a method to our canvas, and we call it clear screen as well, because why not? And clear screen is going to clear the global clear screen. Let's create raw clear screen just to be a bit clear, because this is not doing any logic, it is really just clearing the terminal. And we can do pose X equal at 0, C of pose Y equal at 0. And when we start, one of the first things we want to do is create a canvas. Canvas. By default, pretty much everything is going to be 0. Even though it is by default, like I like to be explicit. And here we're not going to call raw clear screen, but just c.clear screen. Just making sure everything still works. It should be exactly the same. All right. Excuse me. All right. Next step. Next step was to actually display it, but before displaying, we need to keep track of it. So, actually, it was not really a good idea to mix everything up. So let's split it again. All right. So now we are here, we go back to that first thing, and so when we go up, so we say that was up, down, that was right and left. just to not to forget. And we're going to do C of pose. So what is our x? X is the line. So basically when we go up, we're going to reduce the y, because we actually start on the top left. So the top left is going to be 0, 0. So if we go to the next line, it's going to be 0, 1. So basically, yeah, our origin is on the top left. So when we go up, we basically reduce the y. So when we go down, we actually increase it. When we go right, that is going to be x and y, and that when we go right, we increase it. When we go left, we decrease it. All right, that's x we said. And each time, I want to display the coordinates. So we're going to do %d slash %d. Actually, no, let me think. Let's do a new line still for now. It is going to be a bit broken, but we can deal with that later. And it's going to be pose x, c dot pose y. Let's see how that works. Left, right, left, left, right, right, left, left. So that is good for x. If I go up, -1, 0, down, 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 right, right, right. All right. So, a few things. First, we actually did lose our cursor because of the new line. And of course, we can see that we can go off screen, which is not great. So we can just very quickly fix that. If C of pose y is greater than 0, and if C of pose x is greater than 0, so we can never go in negative. We should to do under upper bounds, because eventually we should do that too, but for now we mostly worry about the negative ones. All right, so we are not going to display it like this, and this is where the actually save cursor and restore cursor is going to help. So first thing, we don't do that, and our printf is going to be save cursor. So we said from the docs it was our escape sequence plus 7 or 8. So /033, and no, I don't think there was that. It's just 7, and to restore it is 8. And of course we want to move where we want to go. And for that, we will need to set an x and y, set cursor position, row colon, CSI H. All right. So fmt.printf, CSI was that one, then a number, then a number, then H. And in our case, the number, we said row, then column. So it is going to be the first row. And it is going to be at the right of the screen. Actually, for now, first, let's do at the top left. So what's going on? Save cursor position, move cursor, print UI, restore cursor position. I have no clue if that's going to work, but let's try. And I move, and it looks like it's working perfectly. That is very, very nice. Except, of course, when we go above and beyond. So, because we want to be able to go more than 10 and come back, what we're going to do, we're going to actually like wrap that thing with padding. So that is not going to be printf anymore, it's going to be an s printf, and that whole thing is going to be padded. So I've made printf. Up. So right now, basically, it has no effect because printf just returns a string and then we display it. But now we can do, let's say, how many numbers do we want to have is going to be 4 for the four on each side. So it's going to be plus a slash. It is going to be 9. 4 and 4, 8 plus 1, 9. So we can do space 9. So that means it's always going to display 9 space. And if we put a dot before and after, we can actually see that in action. So here we can see the dots where the dots are. And we can see that we can go back. And it automatically resizes and automatically pads. So that is pretty good. And I think maybe there was like minus to do the other side. I forgot. Nope. Oh yes. Let's go back the dots just to visualize that. Yep. All right, but again, in our case, we want to put that on the right side. So it is not going to be minus, it's just going to be like this, because that was pretty good. And instead of being 0, 0, this time it is going to be on the right side. So in our case, let's say, I don't want to go like all the way down because I would cover it. Let's say we're going to be right here. So stty size 22, 128. So let's say 120. So if we go 120, let's take a look. All right, that works actually very well. That is pretty cool. But as we have our 9, basically we want to do our position -9. And that should be exactly like where we were. Okay, cool. What is going to be our next step? We actually did that. So we have our base of a UI. We keep track of our position. Now let's do it a bit better now. Let's just see like select and set a pixel. So the idea is that with our blank canvas, when I press space, I want to be able to turn on and off any kind of pixel. So how do we do that? How do we do that? That is a good question. First, we need to be able to watch for space. So space is going to be a 1 character. We saw that earlier. And buff of 0 equal space. Printf space. Oops. All right, it does work. And when we press space, we basically want to print the cursor. Not the cursor. We want just to fill the case in white. So for that, it is going to be space. And do we have things with color here? Oh, we do have things with color. So if we have CSI, PMM. So now if I want to do like the background, I want to do the background to be white. Set the background to white. That will be 47. And 49 to reset it. Cool. So here we're going to do fmt.print /033 open brackets. That was the first CSI. Then we said 47 M. Then we actually print our space, and then we reset background. 49M. Of course, we could put everything in the same print statement, but it's a bit clearer like this, I would think. We don't need to actually print F here. We do here and we don't there. All right. Also, I noticed that the UI does not show until the first key press, which is not ideal, but we can fix that easily. Okay, so press space. Awesome! That is super cool. So here we have our basic Sprite Editor, and we can draw whatever we want. Next. Next. Set a color for that. So that is actually a bit more complicated. Let's go back to our color. Those are foregrounds, but I think those are really just for the 8-bit colors. Here we want 16 bits. No, we want 256. 256 colors is going to be 38.5p. All right. Actually, that is something I really like. So 38 for the foreground, 48 for the background, and then the color. All right. Let's hit a pause on what we were doing. Return nil, and let's try to display. So the idea here is that in order to be able to set a color, we basically need some form of UI to tell the terminal to display that color. So the first step is going to display the colors that we can print. Finally print. What do we print? We finish with this. It is going to be our escape sequence. So it was CSI. We said it was what? Right there. We said it was 38.5. So 38.5, and then the color. So we can start at 0, and we put two space, and then reset it. I think it was 0 to do the reset. Yes, P0 normal. Not sure if we need to do it for the background too, but let's see. What is that going to do? Right, nothing. That may actually be expected if it's back. So we're going to do, we said we have 256. So we go from 0 to 255. We put that in a loop. That is going to do F this time. We're going, oh, and I forgot to do the M at the end. That may have been Y, but here we just do our I, and let's do our run. So nothing is actually printing. That is a bit frustrating. Oh yes, because we are in the foreground mode, so we actually need a character. All right, that is pretty nice. Let's go in background mode though, so we can go back to our space. Pretty cool. Pretty cool. Now let's do it a bit better though. We can do that if I model 16 is 0. We do that on a new line. And if it's not, then we don't new line. And of course, we don't want to do that for the first time if I is greater than 0. All right. Why is the first one messed up like that? How do we do it? All right, so now we have a pretty nice we have a pretty nice grid right there. Maybe we can go to 32. Like 16. 16 is 16 times 16. Oops. Yeah, if we do division L, yeah. 15. Yeah. So, now that we have our color grid, we want to be able to actually display it. Then with the arrow that is select 1, then maybe enter our space in order to set the color. That's actually a bit tricky. How are we going to do that? We're probably going to need to have some kind of modes. That is like one mode like which is a canvas, and one mode that is going to be like the color grid. Then we come back. Yeah, I like that idea. I like that idea. We're going to keep that around. That is going to be Frank print color grid. It has no logic or nothing, but that is okay. We go back, just making sure that everything is still working as expected. Yes, I wanted to fix our UI that prints only after instead of before. So we can do that before the read, but still within the loop. Okay, so now as soon as we start, it runs. Now we want to have a mode. We want to go from our canvas to the grid. Well, and remember we're going to have both the foreground and the background. So we're going to say like if we press if n equal 1 and above of 0 equal at F for foreground, for instance, we're going to print print color grid. So first step, just want to display it and to go from the canvas. I press F, and of course everything is broken because we're in a raw mode. So like we are back in raw mode. So now it is /R/N. Let's try again. We press F, and now we have it. All right, still not great, but here we can do like a raw clear screen. That should fix everything. Okay, we have our canvas. We press F, and now we want to be able to select a color in particular. And of course, it's 256. Otherwise, it's going to be lesser or equal. F. All right. Next is with the cursor. Do we have a way to hide the cursor? That's a good question. Hide. Hide cursor. Nice. CSI question mark PML. So it is going to be 25. CSI 25. Question mark 25L. And how do we actually restore that? Show cursor 25. Hide cursor 25 as well. Yes, because of the question mark. Show cursor, that is H. So H is to restore and L is to hide. Let's try that. We said it was CSI question mark 25L to hide it. Nice, the cursor is hidden. And H to restore it. Awesome. So in our case, actually that is quite an interesting issue, because the cursor itself is actually like dependent on the terminal emulator. What we're going to do is we're going to hide it altogether and use an underline instead. So that way we can have both a cursor and see what the cursor is doing. because if I go back to Golang, the issue with that cursor is that it kind of hides. And even if it blinks, there are some terminals that are not going to be able to blink. So I think it's better if we basically just hide it altogether. We said it was like this. So we can say func hide cursor. And so CSI question mark 25L to hide it. Func show cursor. I'm not sure if we're going to use that, but might as well have it. H. And we can do that at the beginning, because why not? I'm going to do like hide cursor, defer show cursor. Let's see. That didn't do what I was expecting. At all. Why? Let's go back to our echo. Here it works. That's a 00. Maybe I made a typo. Backslash 033. Open question mark 25L. Oh, I think the clear screen is actually a reset screen. Right, we can put that here. All right. So that is actually quite annoying because we don't really want a full reset. We will. Let's go to our clear. Escape FF. But that is in Tektronix, which is not really good. CSI J. CSI 3J. Nope. Nope. Where am I? Okay, I'm here. Up. Let's try the escape FF. Nope. Nope. Maybe the CSI? Oh. Interesting. Let's see. Is that going to work? Yeah, no. Nope. Erase, maybe. Escape J. CSI 2J. All right. CSI to J. Okay. Next, being able to underline. It's going to be CSI 4 M and 24 to reset. Except that now that we basically got rid of the actual cursor of the terminal, we basically need to create a virtual one. What did I get started? It's fine. It is fine, it is fine, it is fine. Each time we move, we need to do something. So that is actually moving the underlying cursor that we don't see. And when we move it, we're going to print CSI CSI 4M space and 24 to reset. 24M. All right, let's see. That is interesting. It looks like the reset, the clear screen does not reset the positions. So we're going to reuse that one to make sure that it is indeed the case. All right, so each time I go down, the cursor moves left and right. That is not really what I would expect. Because if we print something, of course we move. Now we should be able to go up and down, left and right. All right. Next step is just being able to make it blink. Do we have something to blink? Start blinking. That is for the cursor. So it's a CSI 5 and 25. All right. 3 CSI 5M and Bethlehem 3 25M. Let's see. It's a bit slow, but that's fine. Cool. And now, each time we move, actually before we move, we want to remove the cursor from where it was. So, how do we do that? Basically, before moving, we just print a space, and we come back. All right. How cool is that? Now we have our cursor, which is underlined and fully controlled by us. We don't need a printf here. All right. What is next? Sure. Let's see this guy. Uh-oh. Yep, we probably should keep track of what is where. You know what? It's been an hour. Good enough for now. we can start again later.